Yeah.
I've already started. Okay.
Let me just give a brief intro here. Good afternoon. This is the last session, our lightning talk, which is one of my favorite sessions. All this group is standing in front of you and snacks. So they will be super efficient and I will be hovering uncomfortably by them. They only have 5 minutes. So we are going to make this as rapid fire as we can. And so with that, I would like to kick it off again. I'm Susan White. Welcome. We are going to start with Hayden Rudd from North Carolina State University. Welcome.
Hi, I'm Hayden Rudd, and I'm a PhD student here at NC State in the College of Natural Resources. And today I'm going to be talking to you about using high-resolution mass spectrometry to evaluate the impact of flood events on North Carolina coastal plain groundwater vulnerability. And our interest in the impact of flood events on groundwater quality was led by 3 main things. First is, as global temperatures are increasing, we're seeing an increase in the frequency and intensity of precipitation events, which means a greater risk of flood events. Second, in North Carolina, we're heavily dependent on groundwater. So over 50% of North Carolinians are dependent on groundwater for their drinking water source. And third, recent studies on groundwater vulnerability have shown that deep wells are more vulnerable to young water or water that's recharged after 1950 and more vulnerable to modern contaminants than we previously believed. And for this study, we partnered with NCDEQ and analyzed 150 groundwater samples from their monitoring well network. And a key element of this project was the use of a new screening technology called high resolution mass spectrometry, or HRMS. And normally regulatory agencies like DEQ use targeted mass spectrometry to detect and test for organic contaminants in water samples. But this method is limited by its comparatively higher detection limits and by the fact that it can only test for known contaminants and things that we have chemical standards for. So when DEQ does targeted mass spectrometry testing of groundwater, it typically has few or no detections of organic contaminants. In contrast, HRMS screening conducts a full scan of the chemical features in a sample and then compares those to chemical databases to identify those chemicals. And so this allows us to identify more chemicals and to identify chemicals with lower concentrations. So in this study, we detected an average of 5,000 organic chemical features per groundwater sample. And of those, we were able to tentatively identify 26 organic contaminants on average. In addition to the HRMS analysis, we also did tritium analysis to provide information about the proportion of young water in these samples. And as this graph shows, for samples collected from sites that did not experience flooding, the relationship between tritium concentration and depth to well screen follows an exponential decay model. So we see this rapidly declining TU level, and that indicates rapidly declining proportions of young water present. And that's the expected relationship. But in the flooded well samples, we did not see the same relationship. As you can see, there are a number of deep flooded wells that have relatively high TU values. And this indicates that flooding is leading to young water intrusion of these deep wells. And when we combine this with the HRMS results, we see that these flooded well samples with relatively high TU values also have above average counts for the number of emerging organic contaminants present. So overall, this study had an average emerging contaminant number of 8.8 per sample. Diving a little deeper into the HRMS results, we had several wells that were tested both before and after flood events occurred. And comparing the pre and post flood HRMS results for these sites, we saw that post-flood, there was an increase in the number of tentatively identified chemicals, the number of emerging organic contaminants, and the number of regulated chemicals and number of chemicals with anthropogenic sources only. This figure shows an illustration of one of those wells where pre-flood we had 2 regulated organics, and post-flood there were an additional 7, but we still detected those same 2 from earlier. So overall, this study, the results show that groundwater in coastal plains is in fact vulnerable to organic contaminants introduced during flood events. And it also shows that HRMS screening is a valuable tool to use to evaluate groundwater vulnerability. And with that, I'd like to thank everyone who supported and assisted with this research. Thank you.
And that's how it's done. Perfect. So we have next up Mahesh Tapas from East Carolina University. Welcome.
Hello, ladies and gentlemen. As most of you know, hydrological modeling is an excellent tool. It helps us understand water quality and water quantity issues in the catchment. But we are living in Anthropocene, where several human activities affect watershed significantly. Therefore, here I am presenting my socio-hydrological model for Eastern North Carolina. Eastern North Carolina is currently facing 2 major issues. First, it is global hotspot for sea level rise. Other, it's changing agricultural practices, as well as CAFOs are is giving a large amount of nutrient load on the watershed. This is my study area. I have delineated my watershed using StreamStats USGS. Most of the study area lies within Tar-Pamlico watershed. My major research question is, how does farmers' perception of sea level rise and excess nutrients affects watershed characteristics? So this is my very basic methodology. What I'll be doing is, I'll be setting up hydrological model. I'll be inputting farmers' behavioral inputs into it, which will give me socio-hydrological model. Now let's go deep into hydrological model. So I'll be setting up a basic SWOT plus model. I will use DAME files through USGS. I'm using land use land cover data through National Land Cover Dataset. I'm using weather data from SWOT, then as Surgo soil data. Then I'll be simulating that model for past 30 years. I'll be calibrating that model for half period and validating for remaining half. This will give me hydrological model using SWOT plus. Now, the new thing I'm doing in this is I'm adding farmers' behavioral inputs into this. So first of all, I'll be identifying several parameters which affects farmers' perception of sea level rise and excess nutrients in the watershed. Then I will develop several scenarios and questions for interviewing farmers. Then I'll be interviewing farmers as well as analyzing their response. Also, from that, I'll be identifying several parameters and inputs which I need to change in my SWOT plus model. Now, I have my parameters which I need to change in SWOT plus model. I'll be dividing those 2 into for sea level rise and 1 for excess nutrients in the watershed, which I'll be inputting in hydrological model. Now I'll run that. Now that hydrological model is transformed into socio-hydrological model. So that socio-hydrological model I'll run with several scenarios. And I can, after this, on this socio-hydrological model, I can test my hypothesis, whether farmers' land use land management decisions affect watershed nitrogen transport and retention characteristics or not. So this is my current status. I have already set up a SWOT model for Tar-Pamlico watershed. I am still running calibration on it. I am calibrating it for flow as well as nutrients. Several works I'm planning to do is I'll be interviewing farmers soon. I'm still developing questionnaires for it. Then I'm still thinking of what are the innovative ways by which I can integrate my hydrological model with farmers' input. Then Apart from that, I'm also looking forward for partnering with others uh, who can get benefit from my hydrological model. So I'm talking with one of the biologists. So she's interested in how decline in fisheries affect due to water quality in the catchment. So I have channel data. With that channel data, I can with SWOT model, I can predict water quality in that particular channel. And she has shape file for that fisheries habitat. So by matching those two, we can predict what are the reasons behind those fishery laws or that changing habitat. Thank you so much for your patience listening. If you have like anything which we can collaborate with our SWOT plus model, feel free to contact.
All right, we have an online version, so we need to switch over. Do I need to do anything from up here? Stop share. Perfect. Great. We have Destini Petite from UNC-Charlotte. Welcome.
Thank you. Can everyone hear me fine? I hope so. I can hear myself, so that's good.
Yes, we can hear you fine. Thank you.
Okay, perfect. So today I'm going to talk to you about one of my dissertation chapters, which looks at the effect of stream restoration on baseflow suspended solid dynamics in urban forested streams. And I want to start by saying that suspended solids are the leading cause of surface water quality degradation in the United States. And while the bulk of those suspended solids are moved during storm events, we also need to understand what is happening during our base flow, which is what our systems are at most of the time. So my study location is within Mecklenburg County. It's in Charlotte. It's an urban forested stream. It's the Reedy Creek Nature Center and Preserve, if you're familiar with the Charlotte area. And this is about a 6 square kilometer watershed that has undergone priority 1 restoration throughout the entire watershed. And some before and after pictures to show you here. The channels were very channelized, highly incised, really fast flowing streams with lots of erosion happening in this before picture. After restoration, we have a more natural channel shape, more sinuosity, slower flows, and ability of our floodwaters to access the floodplain. For this dissertation chapter, I had a research objective of quantifying the total suspended solid concentrations before and after restoration. And I hypothesized that we would see a decrease in baseflow total suspended solids at the watershed outlet. And that's due for a variety of reasons. So one is that we have a change in the channel morphology. It's no longer straight and channelized. We have that more sinuosity. We see the addition of bed features that we didn't have before restoration, such as these rock weirs and ripple pool sequences. We also see an increase in channel depth and a shift from a sand and gravel stream to a more clay dominated bank and bed after restoration. So we collected weekly total suspended solid samples from 2016 all the way through 2021, which happened to be a 2-year pre and a 2-year post restoration study. We took samples from the streams. We took 1 liter samples. We took them back to the lab. We ran them through GFF glass filters that were pre-weighed. We filtered a known volume, dried that filter, and then reweighed it to get our total suspended solid concentrations. So here are the results for this dissertation question. We see that overall, there was a decrease in average total suspended solid concentrations in the post-restoration period. Pre-restoration, we were looking at a concentration of about 19.7 milligrams per liter. And then post-restoration, we saw that decrease down to about 7.27 milligrams per liter. If you look here at my line graph, you'll see that in the pre-restoration period, which is here on the left, we see lots of total suspended solids flowing through the watershed. The orange bar represents the restoration period. It was roughly 1 year exactly. And then we have our post-restoration period. So you can see that there is that decrease over time with this restoration approach. And we also see that this is a statistically significant decrease in total suspended solid concentrations. So in conclusion, we see that restoration at this level, so that whole watershed level, that 6 square kilometers, we see restoration at that level does have the potential to decrease those total suspended solid concentrations. And generally, we're seeing a more stabilized watershed. And again, that could be brought on by slower flows. And those slower flows are brought on by channel morphology changes, again, channel bed feature changes in depth, slowing the water down. And again, a shift from that sand and gravel, so more easily eroded material, to a more clay-dominated bank and bed. So with that, I'd like to thank you for listening. I'm hoping to defend my complete dissertation over the summer. So if you're interested in attending that or want to learn more about my research within the watershed, you could scan this QR code or check me out on Twitter or send me an email. And finally, I'd like to just acknowledge the field crews that have helped with this research. This project started in 2012, so it's been a very long project. I'd also like to thank the City of Charlotte and Jason Hunt, as well as funding for my dissertation that was given through Charlotte-Mecklenburg Stormwater Services. Thank you.
Wonderful, thank you. Bear with me, we are. All right, great. Next, we have Amanda Johnson with the Carolina Wetlands Association.
Hi, good afternoon. My name is Amanda Johnson, and today I will be discussing the importance of small wetlands, how they're regulated in North Carolina, and what we can do to protect them. Here we go. Despite their size, small wetlands, 1 acre or less, perform a variety of beneficial services, including flood storage, water quality improvements, recreational opportunities, and wildlife habitat. 1 acre of wetland can store 1.5 million gallons of water. This means having wetlands dispersed in various positions across the landscape can reduce stormwater runoff, lessen flood damage, and minimize or even prevent severe overbank flooding events. The water absorbed in the soils helps replenish water levels in streams and reduces drought on land during dry periods. An inch of rain on 1 acre of asphalt produces 27,000 gallons of stormwater runoff that carries a variety of pollutants and causes widespread erosion. Meanwhile, an inch of rain on 1 acre of forested wetlands produces little to no stormwater runoff, and it allows for the natural infiltration process that wetlands provide to improve the water quality. Small wetlands have been shown to be more efficient at reducing stormwater runoff because they have higher rates of evapotranspiration. In 2011, North Carolinians spent $3.3 billion on recreational activities related to wildlife, which means people visiting wetlands can boost local economies. Small wetlands within urban and residential areas can make outdoor recreation activities more accessible. They can also improve nearby property values and promote healthier lifestyles. In the mountains in Western Piedmont, small wetlands are habitat to over 90 species of rare, threatened, and endangered plants and animals. They're also critical breeding grounds for amphibian and crayfish species, and they tend to attract a variety of birds because they're prime nesting and feeding areas. Wetlands are also an important drinking source for wildlife, especially in areas surrounded by uplands. So I won't get into all the different requirements for federal permitting, but I will say that for impacts to federally jurisdictional wetlands, North Carolina has regional conditions that require Section 404 and 401 permitting for impacts that exceed 1/10 of an acre. North Carolina is also currently proposing wetland rules that require permitting for non-isolated wetlands for impacts that exceed 1/10 of an acre. And for impacts to isolated wetlands, requires state permit for impacts that exceed 1/3 of an acre in the mountains, 1/2 acre in the Piedmont, and 1 acre in the coastal plain. A recent study involving over 4,000 field delineated wetlands found that more than half of the wetlands in the mountains were less than 1/10 of an acre. About half of the wetlands in the Piedmont were less than 1/10 of an acre, and more than half of the wetlands in the coastal plain were less than 1 acre. This means that some of these small wetlands can be lost without requiring permitting. So because the size of the wetland is not a direct indicator of how well the system is functioning or the value it has to the surrounding landscape, other criteria should be incorporated into permitting requirements. A landscape approach should be used to avoid and minimize impacts to wetlands that are in the position to provide the most societal benefits. Knowing that some small wetlands can be lost, even with federal and state regulations, there are other things that we can do to protect them. Small wetlands are often missed and commonly used wetland mapping resources. So an updated, more accurate map of wetlands in North Carolina would provide a greater level of understanding of where small wetlands occur, better inform regulations, and potentially streamline the environmental permitting process. Local governments can include development standards and land use plans, include things in their ordinances to prohibit development in wetlands, and also provide incentives to preserve wetlands, such as waiving local permitting fees for projects that specifically avoid impacting wetlands. Education through public outreach is essential to spread the word about how important small wetlands are. Small wetlands offer considerable environmental and economic benefits to North Carolina through the services that they provide, and they should be protected. So with an increased awareness about how important small wetlands are, we hope that we see more being protected. Thank you.
All right, up next, we have Jingyi from UNC-Charlotte.
Good afternoon, everyone. My name is Jenny Key. Also proudly presenting UNC-Charlotte. And the topic of my presentation today is community-oriented diffusion strategy for green stormwater infrastructure. I would like to start with a brief introduction to the green stormwater infrastructure. The acronym is GSI. It is a new type of emerging stormwater infrastructure that provides benefits that more than runoff control. And community-oriented means to listen to the people that matter so that we can tailor the solution that matter to them. In our study, by listening, we mean to collect their opinions related to stormwater infrastructure through an online survey. I will start with a comparison of their actions. As you can see in the two pie charts here, nearly 99% of the survey participants stated that they have engaged in water conservation activities. However, there are 30% less of them that have indicated that they have adopted GSI at their private properties or financially supported communal GSI measures. So what makes GSI less attractive to those who are active in water conservation? Is this really just because of cost? So we followed up with questions assessing their financial willingness and their acceptance to GSI implementation. More than 80% of them express a favorable acceptance level toward GSI. And all statistical numbers in here shows to the question of maximum willingness to pay for GSI measures indicate a moderately substantial financial willingness. So the cost seems less of a concern to the participants of this survey. So what else could it be that discouraged them, their actions on GSI adoption. We then investigated whether unfamiliarity or even the subconscious resistance could play a role, but the combined results from these two, as shown in these two figures, suggested that unfamiliarity have little association with a negative attitude. So we concluded the survey with another question to be addressed. What explains this subconscious affection toward GSI? And one probable answer to the two questions is that there might be some aspect that have been previously underestimated. And one of such is cognitive biases, which are commonly associated with irrationalities in behaviors. And the figure here just illustrates a skeleton of this ongoing research pursuit to this question. And that attempt to adopt the major behavior theories, including the theory of planned behavior, innovation diffusion, to incorporate cognitive bias through agent-based simulation. Please tune in to our update at the next WRRI conference. Thank you.
Wonderful. Okay, we are next up with Deja Drummond from East Carolina University. Welcome.
Hello, my name is Deja Drummond, and I am a sophomore undergraduate engineering student at East Carolina University. And I've been doing research under Dr. Natasha Bell on analyzing recycled and manufactured absorptive materials to reduce phosphorus concentrations in wastewater loads. So the reason for this research is we're understanding the process of eutrophication. And so this is when excess nutrients in water are put into natural bodies of water due to human activity. And this can be from domestic wastewater. And this promotes the overgrowth of algae and results in low dissolved oxygen levels. And so this ends up resulting in aquatic hypoxia, which can lead to fish kills. And this process can be remediated by using recycled and manufactured absorbent materials within a passive filter to reduce phosphorus release. So the previous work done with this research was a column study. And this column study allows us to look at what the wastewater treatment plant would be implemented on a smaller scale. And so we used 15 columns with 3 triplicates of 5 material types. And so the material types were recycled concrete, expanded slate aggregate, expanded clay aggregate, gravel, and plastic pinwheels. And so they underwent an 8-hour hydraulic retention time with an initial influence of around 5 to 7 milligrams of phosphorus per liter. And at the end of the study, we found that 98% phosphorus removal was found with concrete and 79% phosphorus removal was found with the expanded clay aggregate. And this study was run for continuously for 4 months. And so next we did a batch study. And so we used 4 different material types, which were recycled concrete, expanded clay, expanded slate, and gravel as a control. And so this study involved putting 5 grams of different materials into centrifuge tubes with 45 milliliters of treated wastewater. And so these centrifuge tubes had various different concentrations of treated wastewater ranging from 0 to 3,000 milligrams of phosphorus per liter. And then these centrifuge tubes were put into an orbital shaker for 24 hours at 150 rotations per minute. And so we did this to determine the maximum sorption capacity of each material. And so after getting our results back, after water sample analysis, we used a Langmuir model to create these isotherms to determine the maximum sorption capacity for each material. And so we were able to use the Langmuir model to get an R-squared value to see how closely the calculations from the model fit with our actual raw data. And so these were the results from the bat scale study using the Langmuir model calculations and our raw data. And so as you can see, concrete in the blue had the overall highest sorption capacity and was able to undergo more phosphorus concentrations versus the other materials. And then expanded clay, or the filter light, which is in gray, was also doing very well. And so the materials like concrete and expanded clay, they had a very high R² value. So this means that it correlated very nicely with our Langmuir model calculations and our raw data. And so based on other review papers, we can see that our materials did very well in comparison to theirs and some of the similar materials that they had. And so after this, we are going to be analyzing the desorption characteristics for each material. So this means that we are going to be looking at under which conditions these materials are going to start desorbing phosphorus. And so we are also going to be using these materials that have reached their sorption capacity to grow plants. I would like to thank Greenville Utilities for the wastewater treatment plant, and Staylight, Filtralite, and Carolina Concrete Recycling for donating these materials, the ECU ERL for doing sample analysis, and ECU Division of Research, Economic Development, and Engagement for the funding. Thank you.
All right, let's see if we can. I'll just start you on that one. How about that? Okay. So there's been some negotiation within our Division of Water Infrastructure team, who is following up now with 4 back-to-back presentations. So while you might be timing me at 5, I'm going to time the first speaker at 7 because I was told to, which I'm totally fine with. But the other speakers will have to make up for that, right? So they'll have to negotiate. This is Kristin Fertenbaugh. Here you are.
Good afternoon. We're going to be closing out with some super fun funding discussion. So my name is Kristin Fertenbaugh. I'm with the Viable Utility Reserve in the Division of Water Infrastructure. So I'm going to start with a little bit of ARPA background and then talk about the Viable Utility Reserve, which is why I need a couple extra minutes. So first of all, what is ARPA? ARPA is the American Rescue Plan Act. You've probably heard of it. It was passed around this time last year. So we are getting around to starting to administer the funding for this program. The total that came to North Carolina from ARPA was $8.6 billion, which is a lot of money. Now, the allocation that DWI is administering is a disbursement of about $1.7 billion. It's important to note that the state fiscal recovery funds administered through the Division of Water Infrastructure are all grant funds. So this is a big opportunity for a lot of water and wastewater systems and stormwater systems across our state. This is different if you've heard of some of the local recovery funds, maybe some municipalities, you've heard of them already getting an allocation from the Treasury. That is separate from what the Division of Water Infrastructure is handling. Some important dates to note is that the next funding round for the DWI closes on May 2nd, 2022. So that's coming up pretty quick. We do have to allocate all of the ARPA funds no later than December 31st, 2024, and they have to be spent by the end of 2026. So it's a pretty quick timeline. If you're familiar with infrastructure projects, that's not a lot of time for most projects to get going and to get completed and have all of the money spent within that 5-year period. So the Viable Utility Reserve, I'm going to give you guys a quick primer on what this is because it's also brand new. It's less than 2 years old. So it was signed into law in July 2020. The initial funding allocation that we were given was a one-time allocation of $9 million. And I'll show you a slide in a couple of minutes that shows how much ARPA money we're getting. It's a pretty big difference. We'll just say that to start with. So we did create some distress criteria to classify them, classify different local government units, municipalities as distressed. And currently we do have 95 that are classified as distressed. Both the State Water Infrastructure Authority and the Local Government Commission do have buy-in to this designation of distressed, and all the designations do have to go through them. So there's a lot of moving parts involved in getting designated, but because there's only 95 currently designated and we are currently in the reassessment process, so that number may go up. You know, there's going to be a pretty big pot of money for not a lot of people, but that's good. So we do have some requirements. So if a unit does get designated as distressed, it's not just you're designated as distressed and you have access to this other pot of money. It's you get designated as distressed and then you have other requirements that you do have to meet. This includes initial and continuing education on things like utility management, financial management, infrastructure operation and management. So kind of the whole spectrum of, the things a utility staff member might encounter over the course of their work. We do also require that they complete or have recently completed certain types of studies, asset inventory and assessments to kind of know what they have, what condition it's in, where it's at, how old it is, how critical it is, either in terms of what it serves or in terms of if it fails, what does it bring down at the system. Rate studies, so looking at what they're charging their customers, how does that relate to their expenses, their needs, infrastructure-wise and otherwise. And then also they do have to consider merger and regionalization feasibility studies, or MRFs. This could look at neighboring utilities. Maybe they want to merge. Maybe they need to add an interconnection for resiliency. Maybe they want to get rid of their water wastewater system altogether and have someone else take it over completely. It could also look at things like decentralization, because in some cases, a water wastewater system that's not financially viable, maybe it's better to create several smaller systems that are financially viable rather than trying to maintain that one overall system. The other main requirement is that they do have to put into place action plans. They have to have a short-term action plan, long-term action plan, and a long-term financial management plan. So these types of plans might include things like their required education requirement, how they're going to get that, what they're going to do to get that, how they're going to ensure that all their staff attend continuing education. It might include things like what is their capital improvement needs, what sort of infrastructure needs do they have? And then the financial plan is exactly that. How are they going to manage their finances? That's where a rate study could come in and sort of inform that long-term plan. So there's a lot of different requirements. So it's not just you're distressed and here you go. It's you're distressed. You need to do all these things because we want to make sure that that system becomes a viable system. So I mentioned earlier, that 9 million initial allocation. So when the budget passed, you can see that's quite a bit more than $9 million. So we have a lot more money available for these distress systems now. There was just under 90 million allocated in the budget that was already earmarked for specific systems, for specific projects in some cases. But then the division will be administering approximately $353 million that will become available in this first spring funding round that closes May 2nd. So we went from 9 million to over 400 million. So it's a pretty big difference. There's a lot of money to play with. So some closing thoughts on the viable utility reserve. So I mentioned that May 2nd deadline. We'll probably all mention that a couple of times because it's pretty important. The criteria for project eligibility under the ARPA funding does remain the same as the original VUR initial allocation. So it has to be for things like rehab and replacement of existing lines, interconnections, and so forth. But if you are curious about the specific requirements, our website has a lot of great information. You're also welcome to come grab me. I'm wearing bright green today. I'll also be here all day tomorrow. I'm speaking on a panel also about the viable utility reserve. There is a limit of $15 million per distressed local government unit, which includes earmarks. So if those were already earmarked, or conversions from existing SRF loans. So if they do have a loan, then they want to convert it to grant funds, then that will count against that allocation. So we are currently looking at reassessing systems for their distress status. And that's undergoing right now. I'm doing the compliance data for that. So the reassessment scores will also affect the at-risk category possibly. And I'm hoping Matthew was running late, so I'm hoping he's here. Keep going. All right, he's not here. All right, so I'm going to cover the at-risk category as well. So I guess I have another 5 minutes to talk. So the eligibility for the at-risk criteria is in some cases affected by the reassessment scores under the viable utility reserve process. So eligibility by local government unit. So LGUs that have an assessment score of 6 or greater, based on our assessment criteria, and which meet 3 of 5 LGU indicators created by the LGC, the Local Government Commission, or an LGU which serves 1 to 1,000 residential service connections and meets 3 of 5 indicators, but they cannot be designated as distressed. So one of the things that under the viable utility reserve, you can be designated as distressed. There is these assessment criteria. We have 20 indicators. We look at these criteria, we score everyone. But there's also 2 criteria that are not related to that assessment score. Either the LGC has taken over fiscal control or you've failed to submit audits for 2 years in a row, the most recent 2 years. So if you are designated as distressed, you can't fall in the at-risk category, even if you meet these other criteria. And then we do have an affordability calculator, which can show you per municipality or per county if you meet some of those indicators that I mentioned, the 3 of the 5 indicators. There's also an eligibility criteria for project type. So if you have an LGU or a nonprofit water corporation where the primary project purpose, so that has to be at least 75% of the project cost, is for the purpose of connecting residences in disadvantaged or underserved communities to an existing water or wastewater system. So there is an environmental justice mapping tool out there. There's the link here. But also, if you're interested in hearing more about boundary mapping and environmental justice, I'm going to put a little plug in. We're doing a panel tomorrow where we're going to be talking about some of these topics. So if you're interested in learning more about that, there is going to be more information on that tomorrow. So as far as the actual monetary allocation in the budget, it's a little bit smaller than the viable utility reserve, but it's still a pretty big pot of money. There was just under 117 million allocated in earmarks. And then there's about 191 million that will be available for competitive applications starting on May 2nd. So it's a little bit smaller, but it's still a pretty big pot of money. So there's still a lot of money available for these systems categorized as at risk. So the plan for the at-risk funds, it will be available for construction projects and studies, just like the viable utility reserve distress funds. And the criteria for project eligibility is the same as for existing viable utility reserve funds. So that's an important note on eligibility for projects. I encourage you to look at the VUR and ARPA legislation for eligible project types. And there is also that $15 million limit per at-risk LGU. So that has to include the earmarks, conversions of loans on existing SRF projects, construction projects, AIA work, MRF work, all of those things. So with that, I'm going to hand it off to my colleague Kavitha to talk about the other category.
All right, I'm Kavitha Ambika Devi, and I'm going to make up for the time here. All right, so what are your options if you are not at risk or distressed for all those other categories, the other utilities which are not categorized as at risk or distressed? We have this other pot of funds available to do their infrastructure construction works. But most of that funding is already earmarked. That means already the recipients are awarded, means it's already in the budget. It's already mentioned who's getting how much. So if an utility is already earmarked, we have already contacted them. They be up and we ask them to send us an application for that funds, and then we are working on sending out a letter of intent to fund and also drafting an agreement with them to make this construction project progress. And then for our next round, the spring round that Kristin was talking about, the May 2nd deadline, we have this 54 million available for competing. We will be prioritizing the applications based on our existing tool. If you are familiar with the Division of Water Infrastructure, you must be familiar with our criteria for funding and everything. So the only catch for this is we do not have a 15 million cap as the other VU, means distressed utilities. We have only 5 million we can award from this pot of money. But if you have a big project, the cap 5 million is in a grant, but rest we can make it up with an SRF loan, because we are going to have a lot of SRF loan money, reduced interest, 0% interest loans available. We can use that to offset any other project cost. as Kristin was talking about, a construction project takes more than 3 or 4 years to get all the money spent. So this is going to be a very attractive pot of money if you have a project that you haven't quite planned, you're not ready there yet. So we have the more than $77 million of study grants you can apply for. It can be used for an AIA, rate studies, MRF, and also training grants. And this, if you have a bigger construction project and you can use this money to do an engineering survey, the engineering design phase. So you can do all the plans, specifications, get the permits ready and ready to go use this $400,000 as a grant money. So you can be well settled to start your project. So that's a cap I'm talking about, is the $400,000. So next I'm going to invite Logan to talk about the stormwater infrastructure.
Good afternoon, everybody. I'll be talking about the stormwater stuff. And we initially started out with about $100 million from this grant. And from that, about $18.5 million got earmarked to towns that had already been contacted. So with that, there's about $82 million left over. And from that $82 million, it's getting split between 70% for construction activities, whether you be installing a brand new SCM device or rehabilitating an existing SCM or retrofitting one. And then the other 30%, about $25 million, is going towards study grants. So I know a couple MS4 communities are coming up with the new EPA guidance saying that you have to map your stormwater system, so that can fall in there, or it can go towards starting a brand new stormwater utility. There's a slide that we have for the monies. Now, the projects that can be eligible for this, the way to be eligible is you have to show documented stormwater quality and quantity issues, demonstrate that the town or LGU has significant hardships, and that goes back to the affordability criteria that we were talking about earlier. And then another entity that can be included in this is a nonprofit, whether it be a regional council or a nonprofit. And just like everybody was saying earlier, our funding will not be this spring. It's actually coming in the fall, because with this being so new, we're kind of working out the application data to apply for this. So it won't be actually available in the spring, it will actually be available in the fall. So look forward to that, either September 30th. And going back to what my colleagues were saying, for a recap, most of these funds will be distributed this fall or the spring, with some left over for the fall, with the exception of stormwater again. And if you have any questions, here's our information right here that you can contact us with. Kristin and Matthew being in the VUR section, Kavitha being in the drinking water, and me being in the wastewater and stormwater funding section.
Thank you. They kept it right on time. Look, so we're so pleased. Again, let's give a round of applause for all of our speakers. Thank you for taking the time to practice those. It takes some doing to fit it in between 0 and 5 minutes. So we are at our reception. I hope you all take advantage of chatting with the students that we have at our poster reception and enjoying some of the food and beverages, and as well as some of the vendors that we have with us today. So thank you for coming today, and for the conclusion of today, we look forward to seeing you both at the reception and tomorrow morning for day 2. Congratulations, you're done.